So if we go to PRs, I guess I'll just pick a random, well, anyone see a PR they're interested in? Or should I just pick a random one?
We could maybe pick one that was made by one of the mentees.
Okay, so how about use mp.asArray to convert arg to array? Oh, Callion's not here, so does that mean that should we still do that or not? Or is Callion here now?
No, and no, I don't think we should.
Sorry, I've got confused. No, we shouldn't do it, or no, it doesn't matter.
No, so I don't think Callion is here, and I don't think we should choose one of his.
All right, okay.
You can choose one of mine. Like the first one is mine. It's a work in progress, but
okay.
The test is failing, but not it's not.
Well, we can do several. So I mean, we can, you know, after this one, we can always do more, depending on how long it takes. But let's use our time wisely.
Okay, so normally the first thing I think of when I see a PR is to try to work out how much effort I should expend on it immediately. So what I would want to do is check it. Well, first of all, check if there's any tests added and any documentation added. Okay, there are some tests added. So the next thing I would do is try running those and see whether it causes, so see whether the tests that have come with it are working or not, first of all. So I'll check out that branch. I might not have a remote added for this yet. Right. So if I check out this branch, which is called learn/broadcast, and try running that test. Is the bottom of my screen streaming? Some streaming things cut it off because it's not 16:9. Can you see my last line says Python -m?
I can see it, yeah.
It's probably really tiny actually, isn't it? Let me change that. Is that better?
Yes.
Okay, so the test that was added was test array manipulation. What's the name of the class? Oh, I'll just run the whole test file. So I think there's different ways to run the test, but I normally do it through the number.run test module. Then a bit like it's basically unit test with some additions, quite a lot of fancy additions. So you can invoke it like unit test. So it would be number.test. Manipulation. Sorry, I'm just going to have to go back and rebuild LLVM Lite because often I build LLVM Lite for different Pythons in different environments, and I've got that built for, well, obviously the wrong Python, or maybe perhaps not built at all. I think last time I demonstrated something, this is exactly what I had to go and do as well. I just realized I'm testing this with NumPy 1.20 as well, which we don't officially support yet. So this might throw up an error.
You tend to make multiple environments, Stuart, or do you all just have sort of one main one that you're working on, or how do you, what's your approach to multiple environments?
Conda environments or?
Conda environment.
Yeah, I've got, so my approach is to treat them as fairly ephemeral. It tends to be that I end up blowing away. I have kind of one main number one, which I do most of my work with. And then I would, if I'm trying to find out when a regression was introduced, for example, we had something that could have been a regression the other day where we found that the CUDA target didn't work with NumPy ufuncs on scalars like np.sign. I thought, okay, that was the documentation that said that it worked was added with number 0.37. So I just created an environment for number 0.37 to test it. So I created a few other environments. Sometimes I have different CUDA versions in my environment. Sometimes I want number in conjunction with some other package. Like it's quite hard to get an environment that's got both number and QPy in it. Sometimes it's hard to get one with. Sure, I had PyTorch. That can be a bit fiddly. So I tend to have to create an environment because, well, at least on the CUDA side, all the CUDA packages like Torch, TensorFlow, PyCUDA, etc., they all don't play nicely. The Conda packaging, at least, doesn't all play nicely together. Eventually, I tend to sometimes the reproducer for something involves another package as well. So I start to install more and more things into my main number environment, and eventually it gets too crowded, and the Conda solver starts doing funny things. So I tend to remove it then. I created number MP120 because I was testing with NumPy 1.20 for something, right. But in future, next time I recreate this number environment, I'll probably create it with 1.20 so that I've got so that my usual environment is the latest. Now, this does create a tiny little bit of inconvenience in that I have one LLVM light folder and one number folder repository, sorry. And I work with all of those environments with just those two repositories, and I install the, let's rebuild this. What I tend to do is install them into the environment with setup.py develop, like that. So the problem with doing that is that each time I switch to, say I might switch to a Python 3.8 environment, I need to go away and, what's that? I need to go away or I need to go back to my number in LLVM light repositories, clean them out, and then rebuild them because I'm running everything from the repository. It's kind of convenient because I don't have to run setup.py after every change I make. But it's inconvenient in that I have to rebuild with each environment switch. But seeing as I change the code a lot more than I changed my environment, that's a worthwhile trade-off. I think I know what's happened there. I've probably got some. Let's just go back to LLVM light. So this is all a bit of a digression from. A bit of a digression from actually reviewing a pull request, but hopefully I should be able to run that test now. Something's running. While that's running, let's have a look at the test that's been added. So the usual pattern in most number tests is that there's a bunch of functions that are going to be tested. The number implementation is going to be tested that tend to sit outside of the test classes. This test array manipulation is no exception. There's one for reshape, or another one or two for reshape, one for on an array, and one for the NumPy module. So this adds one for NumPy broadcast 2. And then the actual test itself is a method in the class. Oh dear, I must have some sort of local modification as well.
Yeah, I forgot to remove this breakpoint.
Oh, that was you.
Yeah,
all right.
Yeah.
Okay. All right, I'm pleased about that. So my first review comment will be, where was that?
Yeah.
Usually I would start a review because I don't want my comments to start appearing before I finish the review, partly because I might change my mind about my comments before I finish the review. And if the person that made the pull request is on it, they might start acting on them before I've changed my mind. But anyway, there's a test there. What I was about to go on to do was to look at the tests. So I guess I would just read it and get my first impression. It seems like there is a fair few different cases in which this is tested. I presume these are going to be input and output shapes, maybe. So data is input array, and then, oh, that's the array and that's the shape it's broadcast to, right? So being as it's commented that these tests are taken from this source, I would probably be inclined to have a look at the tests that they were taken from, excuse me, and then compare them to the tests that have been added. So normally if the tests are taken from NumPy, then this is getting a bit messy, isn't it? A bit limited on one screen. Guess what I would look for is, are all the tests, do they appear to be the same? Because, for example, if any were omitted, that would imply that maybe there's some limitation. Either maybe it was generally missed by accident, or maybe it highlights that there's some limitation that in a number implementation that ought to be documented. So, for example, I don't see the is that case missing? I think what I would start just to do is just make a note of that on the review comments for now. Next, those tests finished, and there were 3 failures. One of them, if this one was to do with reference counting, the fact the debugger popped up might have had something going on with that. I'm also not sure what button I pressed exactly in the debugger. So I think what I would do at this point is I'm just going to remove that breakpoint and rerun the tests just to make sure. Where was the? This was in, array object. I mean, this is kind of a bit of an unfair review, if you like, because it was work in progress, but yeah. So while those tests are running again, let's go back to look at the test data.
If I can comment here,
yeah, sure.
The third argument that you are looking for, it is the expected output. So rather than having the output hard coded in the data list, I'm computing it in line 289.
Got you. So in fact, this input data is exactly the same as the input data from that test, so that's okay.
Yeah.
And then this input data appears to be the same as that input data, and then does that match that? Yeah. So okay. So this is following the common pattern of computing your expected by calling the Python function. Okay, so that seems okay. You got the test broadcast 2 succeeds in NumPy. I presume test broadcast 2 raises is similar. All right. I'm going to guess that this link just points to the same thing. But lines 260 to 276. And then we've got 0, 1, 3, 1, 3, 2, 3, 4. Okay. Okay, I might then, so all the tests from those test cases appear to be duplicated in Numba. What I might do is a quick search, see if there's any other tests of broadcast 2 that weren't covered there. There is something, but it's to do with subclasses, so I will probably ignore that for now. There's a test that broadcast 2 should return a read-only array, and I would make a note of that in here. My first thought about that is that I think that Numba tends not to respect whether an array is read-only anyway. Does that sound consistent with the truth? For example, like we take when we adapt an array to pass it from when we unbox an array, we get a view of the array, which is technically a read-only view anyway, and then grab the pointer to it and pass it into Numba. Is that or the compiled code? Does anyone know what I mean?
Yes. So what about the read-only bit? I missed that.
The read-only bit is that in let me think where it is. So it's typing Q after Numba. One of these files where we, I know it's called something like adapt array or adapt ND array.
Oh, are you saying that those flags on the NumPy object propagate correctly?
I'm saying let's have a look at I'm saying that when you unbox an ND array, you get this buffer or something or a view, and that buffer is read only. But we just use it anyway for writing to the array.
Oh, okay.
I can't remember which file it's in though, so I can't remember the exact name of the function to search for, and I also think I'm going way off track here. From what the purpose here is to try to explain what I would do with a PR. Do you mind if we move on from that?
Yeah, let's move on.
Oh, okay. So there are still 2 test fails, and so if I were actually reviewing this, then I would make a note of these failing tests, and probably I might start to have a quick look into it myself to try and work out why it was failing, to try and make a suggestion about what to do next. I think it would be better if I were to just kind of try to cover the general approach here rather than finish this review, because it would take me too long. So the next thing I would look for is there any documentation changes? I think this would need a documentation change to suggest that broadcast 2 is now supported. So I might then let's make a bit more space. Then at this point, I might start to look at the code. Just does it seem to fit in with the style of Numba? Is there anything that looks weird about it? I'm not that familiar with the implementation of NumPy functions, and not so much also with using intrinsic and overload as much, because I normally work on the CUDA target and it's all the low level interface, so I might just skim through this line by line and see if anything looks odd. Feel free to anyone to mention anything that looks eyebrow raising.
I would usually pay special attention to anything that modifies reference count. Make sure it is like doing the correct thing, like that return borrowed.
Yeah.
Yeah.
Yeah, the alternative is it could be import rep on tracked, and like which one is the correct one to use in this case, right?
Mm-hmm.
Yeah, okay, so that's something to think about, but I won't dig in now. And for broadcast 2, what are the cases that what are the typing cases that it's handling? So the type could be a tuple or a number. Are those the only cases that need handling? Maybe there's other cases as well that have been missed off. For example, what if you passed a list as the shape? I don't know, that might already have got canonicalized into a tuple somewhere else, but it's something I would wonder. And then if that's the case, what does the implementation for each of these types look like? Okay, so overload in this case is kind of just a wrapper for the intrinsic. The difference between overload being and intrinsic allows you to write a function that uses the LLVM's IR and CGUtil's IR building APIs to implement a function, and overload the functions that you return for the implementation are Python functions that get compiled as if they were no Python no jitted functions. So the implementations of those look okay. This is the case for the typing error, and this raises a typing error. Now I would go back to the tests and check, is there a test for this error, or are they only testing the successful positive cases? So there are some tests here for the typing error and value error. One thing I might suggest here is check that the error message matches the error message that we see in the code above. Otherwise, we could be getting a typing error for a completely different reason. Maybe something even isn't working as it should be. So I might add that to my notes as well. For a first pass, that would probably be as far as I'd get at this point. I would then go back to my notes and just write up, trying to be both gracious and polite. Thank you for the pull request, and essentially acknowledging the amount of effort that someone's put into making an external contribution to Numba, and try to be as constructive as possible in writing this up and suggesting what the best way to move forward is. I think in this case, because we've got a couple of failing tests and I'm asking for the typing error message to be checked, I would probably hit request changes in this case. I wonder if anyone else thought of some things that I failed to mention in this summary of a review.
Maybe not not on the first pass review. Just usually additional things that I would do if we pretend this is like already marked as ready for review, not in progress, then I would look at the NumPy documentation on the function, this broadcast2 function, and compare what's the implementation and what's is officially supporting NumPy, and also try some edge cases on the implementations, especially ones that is documented in NumPy, but not sure if it is implemented in the same way in the PR.
Yeah, so spending a few minutes trying to break it is a good way to expose a few things that you might want to comment on.
Mm-hmm.
Just trying to think if there's anything else I might do if this is also marked as ready for review rather than work in progress.
Oh, sorry, I was kind of in and out there, but does this have a test for broadcasting a scalar?
Good question. Possibly not.
Oh yeah, the first couple ones are scalar. The first 3.
They are they scalars or zero dimension? Like when you say a scalar, did you mean like a Python
Well,
scalar
those-
or just a zero dimension? Oh,
Yeah, 0 dimensions. Yeah, exactly.
Yeah, it might, but now you mention it, might it also make sense to have a test for a scalar
That is not
if
a
that's
NumPy
supported?
array, you mean?
Yeah. If that's supported, I don't know whether that's actually supported with this method.
Mhm.
Also, are there tests that will fail because it will be incompatible incompatible with the input? This is the destination shape.
Oh yeah, that's a good. Yeah, I guess that there must be some of them in here. So, like maybe these are ones like that. I'm not sure
Yeah,
where the
these are the ones.
okay. I'm not sure from the above code where the value error comes from. Maybe I wasn't studying it properly. Oh, it's there. Okay, got you. So I would probably comment that message should also be checked as well then.
Mm-hmm. But the checks only checks for negative.
Oh right, okay. Maybe what was the test cases? Oh right, okay. Does that mean?
Like,
Yeah, it is missing. It is missing another check.
Okay.
Oh okay.
Like the NumPy code contains 2 checks. One is for negatives, and the other one is if the shapes match.
Okay. So does your present implement? Oh right. Look, we've got this. These are this is the what I didn't look into earlier, right?
Yeah.
The value error is not being raised. It's just doing something,
Yeah.
doing something bad.
I forgot, but in Numba here, at the point you get to typing at this level, the shapes are all, like you can compare shapes as equal without a problem, right?
I think you can compare the lengths of the shapes if it's a tuple. I don't think you.
The actual
No.
shapes themselves, that's a different story. Because they could be dynamically computed. No, that wouldn't. Well, yeah, you can do that.
Yeah. So I think so here, like, you know what the length of the tuple shaped tuple is, but you don't know what the and then inside impl, you know what the actual values of the shape is.
Okay, good. Yeah, because I was saying it's very similar to the symbolic situation that we deal with, where at a point we can't really compare. If one of the dimensions is said to be broadcastable, but in reality isn't, then you can't tell that until runtime. But I guess you just do it this way.
Yeah. It's very difficult to think and talk at the same time.
Something that I would question, and I did question myself while working on this, is there a way to merge these two implementations? Like there's one for unit tuple and another one for number.
A way to merge what? Hello.
Sorry, merge both implementations. Like there is one implementation for unit tuple and another one for number. And like they are practically the same.
So
Except for
inside
the-
broadcast 2, like the branch, there's a branch that checks if shape is a tuple or if shape is a number.
There was something like this, like macros used to do this for the CUDA target. Like it would automatically convert a scalar into a tuple of length 1. Is there a way you can get it to insert the creation of a tuple, like the conversion of a scalar to a tuple just before the call?
No, we cannot do that currently.
Okay.
And if we also don't have this instance with that branch elimination. That will be what's needed to potentially cast an integer or actually convert the integer into a shape, a tuple. Yeah, it currently will require the two implementation. Now I'm wondering if maybe a little one way to do it, if you want to reduce the amount of code duplication, the integer version could call back into NumPy broadcast 2, and you just explicitly convert the shape integer into a tuple, so that the integer version actually calls into the tuple version. And recursion does work in this case. It should, at least.
And I would imagine LLVM probably inlines the call anyway, so you probably end up with the same result.
Mm-hmm. Yep.
That's probably sort of like an acceptable medium, isn't it? Halfway.
Yep. I think, is that all for the first pass review?
That's all. That's all I can muster.
Right.
Was that helpful, or not?
Yes.
Yes.
Okay, then I think I'm going to stop sharing. I will stop recording.
Okay. See if I can